Today we are talking about wind. Wind, in general, is just movement of air from high pressure areas to low pressure areas. So pretty simple definition. So wind is just the movement of air from high pressure areas to low pressure areas. And you see this little animation here, and just kind of remember this, and we're going to be saying this over and over and over again. Wind always goes from areas of high pressure to areas of low pressure. And we learned about high pressure areas in physics, and basically fluids always try to get out from high pressure to low pressure. They're going to be going to the low pressure areas. Some other things about wind we can see on this sheet or on this slide. A wind gauge here, kind of technical name for the instrument that measures wind, okay, is an anemometer. So anemometer, okay, measures wind speed. Just wanted to show you that. Also, for some of the basics of wind, I wanted to show you if you're looking at a weather map, and we're going to talk about forecasting later, but it's a good time to introduce now because we don't have as much to talk about now. When you're looking at a weather map, you'll see symbols like this on the different cities, and that will indicate the wind speed. So for the wind speed, you're looking at this part of the symbol. Okay. How many barbs it has here? That is the wind speed. So this one has a half barb and then a full barb, so a barb and a half on there. So then you just look at a key and you say, oh, that's 15 knots. Or lots of times they'll do it in miles per hour, and that'll be 15 miles per hour. So a full one is usually 10, and a half of one is 5. But you always want to look at the key, of course, to see what it is. So this one, again, you'd look at it, oh, it's a barb and a half, so it's probably 15 knots or 15 miles per hour. See the two barbs, about 20. If it's a triangle, it'd be 50. So in this one here, it would be the triangle for 50, the full barb for 10 is 60, and the half barb is 5 for 65. The middle here we'll talk about later, that's the cloud cover. It doesn't really fit with the wind unit. The other thing that fits with the wind unit is direction. So you always want to know what direction the wind is coming from. And the way you look at it is you look at the symbol again and think of it like an arrow being shot. So here's the head of the arrow, the shaft of the arrow, and the feathers of the arrow. So if this was an arrow, it would be flying that direction. If this was an arrow, it'd be flying that direction. So you see on your green sheet there, I said wind is always named by where it comes from. So for example, a northerly wind comes from the north. So you look at this one, this wind is coming from the northeast, so you'd say that's a northeasterly wind. This wind here is coming from the southeast, so that's a southeasterly wind. If I had one, let's say, that looked like this. Let's say I have that. You'd say which direction wind is it? Okay, it is a westerly wind. It means it's going west to east. Think of it like an arrow being shot. And it's going 25 miles per hour, or maybe 25 knots. So that'd be a westerly wind at about 25 miles per hour. So that's how those symbols work. Now, we're still talking about this high pressure to low pressure. Okay, air moves high pressure to low pressure, and it wants to go straight from high pressure areas to low pressure areas. But if you remember when we talked about hurricanes, wind is not allowed to go straight from high pressure to low pressure because the Earth is spinning. So we have the Coriolis effect. I said you should remember that from our hurricane unit, and if you can't remember it, you could rewatch that video from the hurricane unit because I'm not going to go into it a lot here. We watched a couple little YouTube clips and stuff in that section. But basically, what the Coriolis effect is, it's a deflection or turning of wind and ocean currents caused by the Earth's rotation. So I said again, imagine the same picture I had before. Imagine you're shooting a missile and you are trying to hit this target here. You fire your missile and it's going this way, but as it's going, the Earth is spinning. So instead of hitting here, it's actually been deflected and you hit here. Maybe you hit where you don't want to hit. And because the Earth is spinning, it appears, or the wind gets deflected. That was why hurricanes spin, if you remember. the wind was trying to go right straight from the highs to the lows, but it had to turn because the Earth is spinning, because of the Coriolis effect. Well, which direction does it turn? In the northern hemisphere, it turns to the right. In the southern hemisphere, it turns to the left. Now, what does that mean for wind? And you see on your note sheet, I have a little area that says high pressure in northern hemisphere, clockwise out, and low pressure in northern hemisphere, counterclockwise in. What I want you to draw next to the high pressure, clockwise out, I want you to draw basically this. You're going to draw an H for your high pressure and draw the winds going clockwise out of the highs. So wind goes out of the highs clockwise in the northern hemisphere. Then for the low pressure, you're going to go counterclockwise and in. So draw that, something like this. So counterclockwise and in for the low pressures. So when you look at a weather map, you look at one like this, you see the H and the L, so high pressure, low pressure, and you see the winds. They're going to go out and to the right from a high, so out and to the right from a high, and then in and to the left in a low. And I'm going to show you some wind here in just a bit, where you can identify this out and to the right high, and into the left low. I really like this idea because then I think you'll remember it if you remember this picture and if you know how to work a screwdriver. Okay. Think of a high pressure as you are tightening a screw. So you're turning clockwise. Okay, you're turning to the right, you're turning clockwise. And if you're tightening a screw, you have to push down. So you're pushing down and turning clockwise. And that's the high pressure. Down and out to the right. Because remember, in high pressure areas, the air is sinking. Remember, air is falling. It's going down, and when it gets to the ground, it has to spread out. And as it spreads out, it turns to the right. So it's going down and to the right from high pressure areas. And that's why they have a picture of a sun here. Because remember, whenever air goes down, it's clear and sunny. Good weather. A low pressure is like loosening a screw. You turn counterclockwise, and then you go upwards. So that's what this is, counterclockwise and up. So remember, the air in a low pressure is rising, and as it rises, it's going to turn counterclockwise. And they put a picture of a cloud here because remember, when air rises, it gets cooler, and cold air can't hold as much moisture, so it forms clouds and rain. So remember this picture. You also see it here. High pressure, air falls, it hits the ground and spins out and to the right. No clouds, good weather. Low pressure, the air rises, and as it rises, it turns counterclockwise. And you get clouds because the water vapor condenses because cold air can't hold as much. We learned, remember, as you go up in the troposphere, the temperature gets colder. We learned that in a couple sections ago. So remember this, and you'll have it. Now what I want to do is I want to show you this picture because I think it's really pretty cool. So it shows you a current wind map, and you can see the speeds of wind. Look at what the wind is doing here. It's spiraling out and to the right, so clockwise and out. So what pressure area is right here? That's a high pressure area. Low pressure, like right here, in and to the left. So there's a low pressure. Low pressure isn't as obvious on this one, but that high pressure is really obvious. Out and to the right for high pressure. I said if we looked at a different day, we could see a really good in and to the left for low pressure. Okay, the last thing I want to talk about for this section is I want to talk about wind chill. And you've all experienced wind chill, and you pretty much know what wind chill is. Let's just say it so we can get it written down. So, wind chill is the cooling effect of the wind. Now, kind of explanation. By conduction, so here's, I'm just use this person as an example. So by conduction, our bodies heat a little layer of air around us, a little envelope of air. So we have a little envelope of warm air around us, and that insulates us and keeps us warm. Well, what does the wind do? The wind blows that little warm layer of air away and allows the cold air to get to our skin so we feel cold. And that's what wind chill is. So you think of on a really windy day, do you want a big heavy sweater or a thin windbreaker? Well, the thin windbreaker is going to help you more than a sweater. The sweater has lots of holes, and the wind can go in through those holes and blow your little warm layer of air away. But the windbreaker is usually plastic and it doesn't have holes in it, so it's going to trap your heat, trap that insulated layer in, and keep you warm. You see on the wind chill chart kind of the big effect it has. So if it's, let's say, 0 degrees outside, but you have a 50-mile-per-hour wind, the wind chill is negative 31. Frostbite in 30 minutes. Okay, what if it's negative 20 degrees outside and you have 20-mile-per-hour wind? It feels like negative 48. Frostbite in 10 minutes. Okay, so again, think about it that your body, you heat a little layer of warm air around you. The wind blows that away and lets the cold air get to your skin. So it feels colder than it really is. Again, that's how a windbreaker helps. That kind of really plastic with no holes, it keeps the wind from getting through and blowing your warm air layer of air away. Now imagine you're wearing a t-shirt underneath your windbreaker and then you bend your arm and that windbreaker touches your skin and it feels really cold. Okay, well that's because you didn't have that insulating layer between you and that cold jacket anymore. Okay, but at least it's keeping out the wind and the cold air. I like this formula. It's always show this formula. You will not have to use this formula, obviously, but that is how you calculate wind chill. That's kind of a tough formula. Okay, and that's it for this section.